Hi everyone, and welcome to Unit 5 Chemical Reactions and Section 1 Chemical Equation. Before we start getting into the reactions themselves, we have to know how to read them. Chemical changes indicate that a chemical reaction has happened, and a chemical reaction is anytime we have substances that are changing into other substances. So the example in this picture, we have potassium chromate mixing with lead acetate, and we get a yellow precipitate. So by definition, a chemical equation is really just a visual statement of what is happening in a chemical reaction. So when you're looking at a chemical equation, like we have here for sodium combining with chlorine to make sodium chloride, this is really just a statement of what the chemical reaction is actually happening, because like I showed you guys in class, remember that these are actual atoms and actual chemicals that are coming together, and so it's not like it's just something on paper. These are really things that are happening. So this is really just kind of a summary, if you will, of what is happening in that reaction. And when you're doing a chemical equation, you're usually looking at the chemical formulas for those substances. So in this case we have Na for sodium, Cl2 for chlorine, and that combines to make sodium chloride. Now, if you've listened to how I've been saying these chemical reactions, you'll notice that I'm talking about things that are going into the reaction and things that are coming out of the reaction. And these things actually have names. We have our reactants, or the things that are going into the reaction. Those are always found on the left-hand side of the equation. And when we say the left-hand side, we're talking about the left-hand side of the arrow. So the reactants are what goes into the reaction. What we get out, or what is produced, is what is on the right side of the reaction. So it's kind of intuitive if you think about the arrow. These things combine together and it produces that. So the product is on the right hand side, that's what comes out of the reaction, and the reactants are what go into the reaction on the left hand side. Another way to think about this is to think about it as a recipe. So when you're thinking about what's going into the recipe, these are the ingredients for it. This is the process of actually perhaps cooking it, and this is the food that you get out of the recipe, so the product. There are some symbols that exist in chemical equations. The most kind of obvious two are these first two. And that first one is the arrow. The arrow means makes or yields. So when you're talking about sodium combining with chlorine, makes sodium chloride or yields sodium chloride. They mean the same thing. So these are really just what you're saying out loud when you're thinking about reading the chemical equation. The second one is the plus sign. The plus sign means and. So again, back to the previous image when we talk about sodium and chlorine. So sodium and chlorine, and excuse my handwriting, makes sodium chloride. When we're talking about, in this case, we have sodium as a reactant and chlorine as a reactant makes sodium chloride. Now the bottom four here are actually used to notate that a particular substance is in a particular state of matter. So sodium usually goes into this reaction as a solid, chlorine is a gas, and what you get out is sodium chloride usually, which is a solid. So these are just symbols down here that are indicating the state of matter, essentially. So as with most things in chemistry, there's always going to be one tiny little piece that makes it a little bit difficult. And that is this for chemical equations, the diatomic elements. So the diatomic elements are not a hard concept to understand. It's just sometimes hard to remember that they need to be in this state. So these elements, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, if you think about the periodic table, they all kind of exist with the exception of hydrogen. From nitrogen through iodine, what they really create over on that side of the periodic table are from N over to fluorine, and then straight down to iodine. So you'll hear me kind of talk about this as being kind of the upside down L, if you will, and these are the diatomic elements. So what we mean by diatomic is that these elements in nature will normally exist in this state of being combined together in sets of two. So in reference to hydrogen, hydrogen naturally will bond to other hydrogens, and so that's its natural state. And when you make a chemical reaction with hydrogen, then the bond will break, and you're free to have two separate hydrogens. But in nature, they are naturally going to exist together as a set of two. Now, we don't call that dihydrogen, even though when we just came from covalent bonding, don't freak out, even though we know that when there's two of something in covalent compounds with nonmetals, we're supposed to call it di, like dihydrogen monoxide or whatever the case is. But when these are just by themselves, they are not in a compound. Okay, they are a molecule, yes, but they are what we call an elemental molecule. So they're just one element. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine in a particular small molecule. Now, nitrogen, when nitrogen combines with other nitrogen, if you recall from last chapter, it creates a triple bond. Oxygen creates a double bond, and we get these compounds. It doesn't necessarily matter what they look like at this point, because all we're referencing is just the point that they will exist as what we call O2 or N2, F2, Cl2, Br2, I2. That's their natural state in nature. So if you're running across a chemical reaction and it says that it combines oxygen or oxygen gas, then that is always going to be written as O2. If it says you take nitrogen and combine it with fluorine, then you would write that as N2 plus F2, and then whatever else happens. But this is just kind of something that we need to work on memorizing and ensuring that we are remembering that these substances, the hydrogen plus the upside down L of the halogens, oxygen and nitrogen, are the diatomic elements. The last particular point for this section is being able to translate between what we call chemical equations and word equations. And FYI, the definitions, not so hard. Chemical equations, yeah, it has chemicals in it. And then the word equation, guess what? It's got words. Words in it. Okay. So when we're going from the chemical equation, this is what we've been talking about for the first section, first part of this section, where we talked about how this is, in particular, talking about nitrogen monoxide gas combining with oxygen gas. Again, oxygen being a diatomic element. It doesn't need to say that it is two oxygens by just stating it's oxygen, it's O2, makes nitrogen dioxide gas. Okay, and so when we translated that into a word equation, which is really what I just said out loud, it's nitrogen monoxide gas and oxygen gas, or with oxygen gas, makes, or you could say yields, if you feel fancier saying that, nitrogen dioxide gas. And there is a note to be made down here that sometimes you will run across chemical reactions where you do not see, let me change the color, you do not see the state of matter there. It's okay. It's okay. If it's not there, then it's not necessary. Sometimes it's written there, sometimes it's not. It just depends on either the author of the particular piece or on the substances that are in the reaction. Like in this one, they're all gases, and anyone who is a little bit more well-versed on these substances know that they'll naturally exist as gases, so it's not something that always has to be there. Okay, I hope you enjoyed your time with learning about the chemical equations, and run through your practice problems. You can work on your summary if you want to, but please run through your practice problems, attempt them. You will need to look back at Unit 3 and Unit 4 if you've forgotten how to name some of those compounds, things like sodium nitrate and all of that. So make sure you're looking back at that, because in this chapter, a lot of what really hurts people is the remembering of the nomenclature. So please go back and look at that if you need it. Come in Monday morning with your practice problems done. If you are really confident with them, you can look at the key, and then you can move on to the next assignment. If you want a little bit more help with it, that's totally fine. Or if you want a lot of help with it, then we will work together on Monday morning to run through everything and ensure that we are getting it. And I will see you then. Have an awesome weekend.